Hello there! Since we already understood what an atom is, now let's go ahead with the properties of that atom. Like the size, the mass, the valency. Yes, another wonderful concept explained in a very simple manner. So let's begin. Now when we take a pencil, we know each and every part of this pencil, which will also be a matter, is made up of an atom. Well, let's carefully look at the tip of the pencil. Well, this tip of the pencil is made up of n number of carbon atoms, right? Why? Because this tip of the pencil is nothing but your graphite, and graphite is a form of carbon. So this is made up of carbon atoms, right? So if I want to study an atom, what is going to be more simpler than hydrogen itself? Very small, at the same time a wonderful atom to explain us the concept. Let's see. So when we look at this atom is circular in shape. Do you observe some positive charges in the middle? Well, of course, yes. That positive charge is nothing but because of the proton. Now, because we've already understood, this proton is present inside the nucleus. Thus, that red colored circle which is giving us the positive charge is nothing but the nucleus itself. Now, above this nucleus, you have another circular shape. And what do you think this is? Well, it contains a negative charge, right? Well, this is an electron. Yes, my dear child, this electron and this proton together in a circular structure with a central nucleus forms hydrogen atom. Just tell me, how many electrons do you observe? 1. And how many protons? 1. So this tells us that the hydrogen atom has 1 proton and 1 electron. But again, that brings us to a question, what about the neutrons? Where are the neutrons, right? Well, remember, hydrogen atom does not contain a neutron. It will only have 1 proton and 1 electron, as a result of which the atomic number of hydrogen is 1. Who studied all of these things? Well, initially it was only the scientists who used to bring up theories, who used to bring up postulates. But now, when the science has advanced, we have field ion microscopy techniques, which gives us these dot-like structures over here, which are nothing but the image of another atom of iridium. Every spot that you see over here is the structure of an atom, and that's how we understand that an atom is circular in shape. Well, let's move with the first property of the atom, the size of the atom. Now, when you talk about the size, of course, it has to be a proper measurement, right? So, let's see what measurement can we take. But before that, my dear child, you need to tell me what structure is the atom having. Is it rectangular, triangular, or circular? Wonderful, this is circular, right? Now, if it's a circle, it's very obvious that it's going to have a center and it is going to have a circumference, right? What is in the center? The center is the nucleus. And what's in the circumference? The last orbit, my dear child. So, when you take the distance between the center of the atom and the last shell or the outermost shell of the atom, that provides you with the radius, right? Now, this radius is of an atom. So, should we not call it as an atomic radius? Well, yes, that is what the atomic radius is. You determine the size of an atom by the atomic radius itself. And what's the atomic radius? It's nothing but the distance between the nucleus of the atom and the outermost shell of the atom, which will be called as the atomic radius. Now, the atomic radius is affected by a number of factors. One such factors is the number of shells. You might be thinking, number of shells? Yes, the K shell, the L shell, the M shell, more the number of shells, what will happen to the radius? Will it reduce or will it increase? Wonderful, it's going to increase. So in here we have this knowledge with an example. Let's see. We take three atoms, we take three elements rather. Lithium, sodium, potassium, of course they have their own atomic number which gives us the electronic configuration. So the atomic number for lithium is 3 and the electronic configuration is 2, 1. 2 in the first shell. Well, it's full. So we have another shell, the L shell, right? So in the L shell, we'll have 1 electron. So when you have 1 electron, that makes up lithium having 2 shells. So the size is smaller. But when you look at sodium, look at the electronic configuration, 281. It means you have the K shell, the L shell and the M shell. Shells have increased? Yes. So has the radius. When you talk about potassium, 2, 8, 8, 1. That makes up 19 electrons. And to fit those 19 electrons, you have the K shell, the L shell, the M shell and the N shell. More the number of shells, more will be the atomic radius. When one quantity increases, my dear child, the other quantity also increases. Then what kind of proportion is this? Wonderful, it is the direct proportion. So what do you mean by direct proportion? When the number of shells will increase, the atomic radius should also increase. So that is one factor on which the atomic radius depends. Well, there is another factor on which the atomic radius will depend, and that is the nuclear charge. But just observe carefully. You have nuclear charge directly proportional to 1 upon atomic radius. Well, it's 1 upon atomic radius. So you won't call this as direct proportion. This is inverse proportion. What was direct? When one quantity increases, the other increases. What do you think will be inverse proportion? When one quantity reduces, the other quantity increases. Yes, my dear child. Now to understand that, let us again take certain examples. The first one is of sodium, magnesium, aluminium and silicon. We have their atomic numbers to be 11, 12, 13 and 14. Now, my dear child, when you look at sodium, you have the K, the L and the M shell, right? Now, when you look at magnesium, what is going to happen? There is going to be an increase in the number of electron. And we know that the number of electron will always be equivalent to the number of protons. So when the electrons increase, the protons will also increase, and then there is going to be an increased attraction between the both. So the size, that is the shells, will come a little closer to the nucleus. Just look at that. It is the same shell. It's just the number of electrons which are increasing. And when the number of electrons are increasing and in the same shell, I'm not talking about another shell, it's just the same shell, the number of protons will also increase. There is going to be a force of attraction between the two. And when there's going to be a force of attraction, the atomic radius will decrease, inverse proportion. Let's look at aluminium now. Aluminium will have its electronic configuration as 2, 8, 3. Just tell me how many shells? 3 shells, wonderful. So K, L and M. In M, there are how many electrons in total now? 3 electrons. So will the attraction between the negative charge and the positively charged nucleus increase? Well, of course, yes, it will. It's the same shell. just the number of electrons are increasing, so the nuclear charge is increasing and the attraction increases. So when the attraction increases, it will come a little more closer and the atomic radius has reduced. Let's look at this with the last example, that is of silicon. 2, 8, 4. So what do you think will happen? Yes, 3 electrons will come and the atomic radius will shrink more. So that's why when the nuclear charge increases, the atomic radius will reduce. And when you spoke about the number of shells, the moment they increase, the atomic radius increases. Understood, my dear child? So let's go ahead with another concept, and that is the atomic size and its units. Well, everything in this world has a unit to be expressed. Don't you think that atomic radius is also going to have a unit to be expressed, my dear child? Well, of course it is going to have. And what is that unit? Well, my dear child, that unit is going to be nanometers. But how am I going to relate this with meters? Well, it's very simple. 1 meter is 10 raised to 9 nanometers. What do you mean by 10 raised to 9? This means 1 and 9 zeros. Just imagine, it's so big. That is, the meters is huge and nanometers is small. So you will have 9 times zeros meter when you expect an atomic radius in meters. At the same time, when you talk about that in the nanometers, it's going to be 1 upon 10 raised to 9 meters. Just shift. That's it. Simple mathematics. Right, my dear child? So it's always expressed in nanometers. Now, when you talk about these sizes, initially the scientists thought that it's very simple to compare the size of different atoms with each other. And how did they do that? Well, they brought about a concept of relative sizes. The question is, relative sizes? Well, yes. They compared each and every structure of an atom with a relative another atom. We'll see what that is. But before that, let's see the examples. So you have, my dear child, hydrogen atom. The radius of the hydrogen atom is 10 raised to minus 10 meters. Then when you talk about water molecule, it's going to be 10 raised to minus 9. Hemoglobin, 10 raised to minus 8. Well, this is a molecule, this is a protein, an entire 3-dimensional protein structure. But still, it's going to have a central portion along with which we can measure the radius. So these are the examples of your different substances and their radii.
And yes, please do not forget to like, share, subscribe and press the bell icon.